Hello, I'm Connie Boyd. I teach 7th grade math at West Valley Middle School, and I'm here today to review ratios and proportional relationships. We're going to work on computing unit rates associated with ratios of fractions, including ratios of lengths, areas, and other quantities measured in like or different units. Recognize and represent proportional relationships by quantities. Use proportional relationships to solve multi-step ratio and percent problems. We have 4 activities on ratios and proportional relationships, and labels are the key to success on all of these. It's very important to watch your labels because they're going to help you solve your problems correctly. So our first activity is unit rates. Our vocabulary includes ratios, a comparison of numbers with same units. So here we have 10 stars. We have 4 pink stars compared to 10 stars total. It can be written 4 pink stars to 10 stars total, or 4 pink stars with a colon to 10 stars total. I personally prefer writing it as a fraction because that reminds me to simplify. So 4 over 10 simplifies to 2 pink stars to 5 stars total. 2 yellow stars and 4 blue stars simplifies to 1 yellow star to 2 blue stars. Rate is a comparison of 2 numbers with different units. I can buy carrots at $5 for 2 pounds, or I can buy 3 heads of lettuce for $6.45. That's the rate. But what if I don't want to buy 3 heads of lettuce? I only want 1. What is it per 1 head of lettuce? That is unit rate. It is a comparison of 2 numbers with different units with the denominator of 1. Divide the numerator by the denominator. So I have $5 divided by 2 pounds because the line in a fraction means to divide. So 5 divided by 2 is $2.50, and 2 divided by 2 is 1. So $2.50 per pound. And again, multiple ways to write it. The same with the lettuce. $6.45 for 3 heads of lettuce, divide by 3. $6.45 divided by 3 is $2.15. 3 divided by 3 is 1. And again, multiple ways to write it. Then we have a complex fraction. In a complex fraction, either the numerator or the denominator is a fraction. And then we have a little trick we have to remember. It's not really a trick. It's what you learned when you learned to divide by fractions. You just have to remember that. So the water hose is spraying out at 12 gallons in half a minute. What is the unit rate? So how much is it spraying in 1 minute? So I have 12 gallons for a half a minute, which means 12 gallons divided by half. But I can't have a half, so when I divide by half, I'm actually multiplying by the reciprocal. And the reciprocal means 1/2 times 2 equals 1. The reciprocal is what you multiply the number by to get 1. So 1/2 times 2 over 1 equals 2 over 2, which equals 1. So 12 gallons times 2 minutes tells me there are 24 gallons in 1 minute, or 24 gallons per minute. So our problem today. Solve the unit rate for 180 miles in 3 hours. 180 miles over 3 hours. Divide the numerator and the denominator by 3. I get 60 miles over 1 hour, which is 60 miles per hour. If it is a complex fraction, solve the unit rate for 80 miles in 1/4 of an hour. 80 miles divided by 1/4 an hour. Well, you're dividing both sides, the numerator and the denominator, by 1/4, which means you're actually multiplying by the reciprocal because you have to get rid of the fraction in the denominator. Because 1/4 times 4 equals 1. And 80 times 4 is 320 miles. So 320 miles in 1 hour. Constant rates of change is activity 2. First, I have a proportion, a table, equation, or statement showing 2 or more rates are equivalent. Thus, this table is proportional. We have X representing the gallons of gas, Y representing the total cost. So I'm looking. If it's $2 for 1 gallon, that's $2 per gallon. If it's $4 for 2 gallons, 4 divided by 2 is $2 per gallon. 6 and 3, $6 divided by 3 is $2 per gallon. 8 fourths, $8 divided by 4 is $2 per gallon. Thus, each gallon of gas costs $2. Therefore, yes, it is proportional, and I can solve that with an equation, y equals 2x. If I take 2 times 1, I get 2. If I take 2 times 2, I get 4. I take 2 times 3, I get 6. 2 times 4 is 8. 2 times 5 is 10. 2 times 6 is 12. Therefore, it is proportional. Constant rate of change is the rate of change that stays the same. Thus, it is constant. I have the equation y equals kx, where k is the constant. If the relationship is proportional, then it's also known as the constant of proportionality. And I have the same chart here. And again, everything comes out to $2 per gallon. It is constant. And we started at 0. We didn't have anything to start with. We didn't have to pay anything up front. So our first coordinates are actually 0, 0. And that's not shown on this chart. So it goes through 0, 0. And everything comes out to $2 per gallon. Thus, 2 is our constant rate of change, also known as our constant of proportionality. So, we're going to buy some ham. We want to know, is this relationship proportional? First, we got to divide. Cost divided by pounds, or y divided by x. So I have 0, 0. 12 divided by 3 is 4. 24 divided by 6 is 4. 36 divided by 9 is 4. Yes, it is proportional because it's $4 per pound. Thus, our equation is y equals 4x. Activity 3, percent increase and decrease. First, a percent, as a reminder, is a number or ratio expressed as a fraction of 100 or part of 100. And I've demonstrated here percent, 60%, and percent out of 100, 60 over 100, which simplifies to 6/10 as a fraction. Or the decimal is 0.6, 0.6 or 6/10. We can add and subtract percentages, but when we do anything with multiplying or dividing, we must use either the fraction or the decimal to change it. Percent of change. A percent in a quantity is described as a percent increase or percent decrease. To find that, first you have to find the difference of the change. How much did it change? O divided by the original amount. That gives you the decimal, and you take it times 100 to get the percent of change. So, if we're shopping for a gallon of milk, in 2010, it was $3.15. Today, it's $4.99. So the difference, $4.99 minus $3.15, and always make sure you put that in parentheses or get the total before you hit the divide by 315 on your calculator, times 100 gives me 58.4% increase. And it doesn't matter the order, but always subtract the high minus the low. You can always tell if it's increase or decrease if they ask you that question. You do not need to mark it positive or negative. So just go high minus the low. So an example, let's look at your math grades. If your math grade goes from 65% to 95%, what is the percent of change? 95 minus 65 divided by 65 times 100 gives you 46.2% increase. If your math grade goes from 85% to a 55%, what is the percent of change? Again, find your change, 85 minus 55, divided by 85. Take that times 100 to change your decimal to a percent, and you get 35.3% decrease. Activity 4, applications of percent. Sales tax. Got to pay tax, guys, when you buy something. A tax on the sale of goods or services calculated as a percentage rate. You're given the rate, then you have to convert that into money. So the sales tax rate divided by 100, change it to a decimal, times the price of an item equals the sales tax. So if a gallon of milk is $4.99, the tax rate on groceries is 7.25%. So change percent to a decimal by dividing by 100, then take it times $4.99. You get 0.361775 on your calculator. But we're talking money. We only want 2 decimal places. We're rounding to hundreds. Remember, 5 or above, you add 1. Less than 5, you let it be. So this becomes 36 cents. So the sales tax is 36 cents for a gallon of milk. If you don't round correctly, you will miss it. So make sure you practice your rounding. Then you find the total sales price. This is when you add the cost of the items purchased to the sales tax. So again, finding the sales tax. Gallon of milk, $4.99. Tax rate is 7.25%. Change percent to a decimal by dividing by 100. Take it times $4.99, you get 36 cents. The total sales price is $4.99 plus 0.36, which gives you $5.35 total that you have to pay for your gallon of milk. So we're going to the grocery. We're going to buy eggs for breakfast. If eggs cost $2.85 and tax is 7.25%, how much is the tax and how much is the total cost? So first, 7.25 divided by 100 times $2.85, the cost, you get 21 cents tax. So the total is $2.85 plus 21 cents for a total of $3.06 for your dozen eggs. We also have simple interest. This is if you're buying a bigger item and you borrow money or you have money in a savings account. So interest paid are calculated on the original principal amount only of a loan or money in an account. Interest equals principal times the interest rate over 100, because you got to change percent to a decimal, times time. Typically it's in years, periodically it's in months. It's known as I equals PRT. Note when multiplying or dividing, change percent to a decimal, thus dividing by 100. Simple interest. Again, know what all these terms are. So interest is the amount of money the bank pays to use your saved money or the amount you pay the bank to borrow its money. Principal is the amount of money in your savings or the amount you borrow from the bank. Rate of interest is your percent rate on money saved or borrowed, and time is the number of years money is saved or borrowed. Lots of vocabulary in this one. So you're buying a car for $15,000. The bank's interest rate is 3% per year. The loan is to be paid off in 5 years. Calculate the interest. So the principal is $15,000 because that's how much you're borrowing. The interest rate is 3%. The time, it says, is 5 years. Always watch for the numbers to be in words. I equals PRT, so interest equals P, 15,000 times the interest rate divided by 100 to change it to a decimal times time, 5 years. When you calculate that, you get $2,250 interest for borrowing the money. But that's how much you have to pay to borrow that money. If you want to know the total amount paid, you would add $2,250 to the $15,000 for a total of $17,250. That's how much the car is actually going to cost you. So that concludes our 4 activities. So here's a little challenge for you to check out. Say you're ready to go purchase a car. So go online, select a car, Kelly's Blue Book or somewhere like that, or any of the websites. Get the cost of the car, then calculate the total cost, including tax and simple interest at, say, 2% for 5 years, because interest rates are down right now. So you would need to know the car cost, the tax, simple interest, and the total cost. And then you wanted to, typically we buy a car, pay 5 years on it, divide it by 60, because 5 times 12 is 60, and find out what your monthly payment is. Good luck.